Greetings, companions of the Deep Dive channel. I am the captain, and I'm glad to see you on the deck of our exploration vessel, ready to dive together into the cosmic ocean. Whenever we think of the strangest phenomena in the universe, one image forms in our minds: a black hole. But what if I told you that black holes, for all their strangeness, aren't even the weirdest things lurking in this cosmic ocean? What if concepts exist that make a black hole seem almost normal? By the end of this journey, you will understand why the world's greatest physicists believe in objects made from vacuum itself, or gateways that open to other universes. But first, we must begin our voyage from a much more familiar place, from these very black holes. Because knowing this story will change your perception of reality. Let's travel back for a moment to 1783. An English scientist named John Michell, using Newtonian physics, proposed the idea of a dark star. A star so massive its escape velocity would exceed the speed of light. 133 years later, Einstein's general relativity placed this idea on a firmer foundation. But it took nearly 200 years until the first real black hole, Cygnus X1, was confidently discovered in 1971. This long wait proves the cosmos is full of ideas waiting to be discovered. And this is where our main question arises. What other monsters are hidden in the equations of physics, waiting for us to find them? To understand this, we need to know how a normal star works. Consider our sun. Its immense gravity wants to crush everything toward the center, but the radiation pressure erupting from its core pushes outward. These two forces in a cosmic dance keep the star in balance. When a star's fuel runs out, this balance is disturbed. It collapses under its own weight and becomes a white dwarf. Here, a quantum force called electron degeneracy pressure prevents further collapse. But this resistance has a limit, called the Chandrasekhar limit. If the star's remnant is heavier than about 1.4 times the mass of the Sun, even this pressure gives way. The star becomes a neutron star, where neutron degeneracy pressure holds back gravity. But there is still a bigger but. If the remaining mass is even greater, about 2.2 solar masses, then no known force can stop gravity. The star collapses into itself forever, and a black hole is born, a point where all the laws of physics break down. This is the story of ordinary matter. But physicists asked, what if a star were made of exotic matter, capable of generating an even stronger pressure? This is where we enter the realm of theoretical monsters. The first creature we encounter is a cosmic ghost, a gravastar. It looks exactly like a black hole but has one crucial difference: no event horizon. This means escape is still possible. What is it made of? The answer is even stranger: dark energy. At the heart of a gravastar, a negative pressure creates a repulsive gravity that counteracts the attractive gravity of its positive energy, creating a perfect balance. If you were inside a gravastar, you would feel no force, as if floating in a vacuum. The gravitational pull and push have completely canceled each other out. It is a bubble of space-time itself, pretending to be a star. Are the objects we call supermassive black holes really these phantom stars? Perhaps we have been looking at ghosts all this time without knowing. But these ghosts are a trifle compared to the lost twin of black holes. To find it, we must dive into the mathematics of relativity itself. Imagine an ice cream cone and a traffic cone. In our world, they are different, but in math, they are two halves of a single shape. Black holes are the same. What we see is only half the story. The complete equations also describe another half, a mirror image. On a Penrose diagram, a map of space-time, our universe is one region. The black hole is a region you can enter but never leave. But the equations also predict a third region, a white hole, where nothing can enter and everything must exit. It's a cosmic fountain, a perpetual explosion. For a long time, physicists thought white holes were just a mathematical curiosity, but newer theories like loop quantum gravity tell a different story. This theory suggests that when a black hole evaporates down to a subatomic size, it undergoes a quantum event and transforms into a white hole, returning everything that ever fell in back to the cosmos. It is a complete cycle of death and rebirth. The story gets even crazier. For a rotating black hole, the diagram shows a path connecting our universe to a parallel one, a wormhole. You could enter a rotating black hole, pass through the wormhole, and exit from a white hole into a new universe. Some physicists even propose that our Big Bang was a white hole, the output of a black hole from a parent universe. All these strange objects lead us to a larger, more profound question. A question that has led to the worst prediction in the history of physics. This is where the story turns. We're no longer looking at the wonders inside the cosmos. We're looking at the cosmos itself. Why is our universe's expansion accelerating? An invisible force, dark energy, is inflating space-time. The amount of this energy is a tiny number, perfectly fine-tuned for our existence. If it were slightly larger, stars and galaxies would never have formed. If it were negative, the universe would have collapsed. We live on an incredibly fine razor's edge. The problem began when physicists used quantum field theory to calculate the value of this energy. The answer they got was a catastrophe. The theory's prediction was 10 to the power of 120 times larger than what we observe. This isn't a mistake, it's a scream, telling us we have fundamentally misunderstood something. Our story is no longer about strange stars, it's about why we are even here to think about them. Why is our universe so miraculously fine-tuned for life? One explanation is intelligent design, a philosophical belief outside the realm of science. But the second path leads us to the most expansive idea the human mind has ever contemplated, the multiverse. This idea suggests there are infinite other universes, each with random laws of physics. In the vast majority, the amount of dark energy is hostile to life. They are dead universes. But in this cosmic lottery, one universe by pure chance gets a value for dark energy that allows life to emerge. And we, as living beings, can only find ourselves in such a universe. It's no longer a miracle, but a statistical certainty. We are here because this is the only place we could be. Our journey began with black holes, led us to cosmic ghosts and interuniversal gateways, and ultimately ended with the deepest question of our own existence. Thank you for joining me on this deep dive. We at Deep Dive are a family of curious minds who aren't afraid to ask the big questions. We love you all very much. And now I ask you, if you could ask the universe one question about these mysteries, what would it be? Write your answer in the comments. I'm eager to read them. Don't forget to help us arrange more exploratory journeys by liking and subscribing. Until the next voyage, farewell. And maybe the next time you look at the night sky, you'll remember that